Okay, now we're going to graph by plotting some points. Y equals 4 times 2 to the x. And I've chosen just to use the values from -2 to 2 because I get to pick. All right, so in this first one, it'll be 4 times 2 to the -2. Right, I'm just plugging in for x equals -2. That is 4 times 1/4, which is 1. See that? 2 to the -2 is like 1 over 2 squared. That's 1/4. Right. 4 times 2 to the -1 is 4 times 1/2, which is 2. Right. 4 times 2 to the 0 is 4 times anything to the 0 power is 1. So that's 4. 4 times 2 to the 1st is 8. And 4 times 2 squared is 16. So let's plot those 5 points and see what they look like. Again, I chose the x values from -2 to 2. So on my graph, I'm just going to show -2 to 2. And my y values go from y equals 1 up to y equals 16. So I'm going to make this like 5, 10, and 15. And then I'll plot my points. Does that stick? Yeah. -2, 1 is here. -1, 2 is here. 0, 4 is here. There's the y-intercept. 1, 8 is here. And 2, 16 is here. So can we see the shape of the graph? Right? So it looks like this. So it's still exponential growth because that number 2 is greater than 1. That's what makes it exponential growth. Did that change the asymptote? No, it's still approaching the x-axis, but there's nothing we could plug in here that would make it touch the x-axis. So the asymptote is still in place. You know, what did it change by putting that 4 in front? Yeah, it did. How about the y-intercept? What is the y-intercept? 4, right? So notice again, that value right there, if there's an a value there, that is the y-intercept, right? Because again, the y-intercept is the value of y when x equals 0. But if x equals 0, anything to the 0 is 1, so y equals 4. And the previous one, y equals 1. So especially when you get to word problem kind of things, like physical problems, and you will, not just in this class, in biology kind of classes, population problems, use exponential growth. You know, usually what you would call the initial value is the value of the function when x equals 0. And so this value here is generally the initial value. Because it's what the value of the function is if you put a 0 in that spot.